Alright, in our last video for this particular topic, we're going to discuss power briefly. Power is the rate at which energy is transferred with respect to time. And we care about this because, as we've seen throughout this chapter, you need a certain amount of energy in order to have a system behave a certain way. So if your power supply doesn't transfer energy fast enough, you're not going to be able to do the mechanical work that you want to do. Power has its own unit called a watt, so a joule per second is a watt. And this should be a unit you're fairly familiar with because that is the standard unit used for light bulbs in the United States. Since this is a transfer of energy or change in energy with respect to time, power is equal to work divided by time. And remember, work is a change in energy with respect to time. So you can think about this in microscopic increments or macroscopic increments. And since we know that work is equal to force times displacement, we can rewrite work as force times displacement, and displacement divided by time is velocity. So we can also think about power coming from the actual motion of the object. So you apply a force which leads to there being a velocity. And because force and velocity are both vectors, if they are acting in more than one direction, then you need to do a dot product. Because remember, this velocity came out of this displacement, and the force and displacement have to be parallel to each other.